All right, let's talk about something that trips up a ton of people in math, converting degrees to radians. I know, it can feel like you're learning a whole new language for no reason. But trust me on this, getting this one conversion down is the key that unlocks so much in higher level math. So let's dive in.
So, let's just get right to the big question, the one everybody asks. You've been using degrees your entire life, right? They seem to work perfectly fine. So why on earth do we have to learn this whole new system with radians? It honestly feels like we're just making math harder for the sake of it.
And here's the real no-nonsense answer. Because without radians, pretty much all the elegant formulas in calculus just break. They fall apart. For example, the derivative of sine of x is a nice, clean cosine of x, but only if that x is in radians. If you try to do that with degrees, the formula becomes an absolute mess. Radians are, simply put, the native language of calculus and beyond.
Now, the good news here is that you don't need to memorize 100 different rules. There's really just one golden rule. One simple, powerful formula that lets you convert any angle you can possibly imagine. Let's build it together from the ground up. It all starts here. This is the single most important connection to remember, the master equation that links these two worlds together. Pi radians is exactly the same as 180 degrees. This is the bedrock. Everything we're about to do is built on this one fact.
So, from that one simple truth, we can create our magic conversion tool. We just start with our master equation, pi radians equals 180 degrees. Now, what if we just want to know what a single degree is worth? Well, we just do a little algebra, divide both sides by 180. And what does that give us? It tells us that one single degree is equal to pi over 180 radians. That little fraction is the key to everything.
And that brings us to the formula, the one you're going to use every single time. To turn any angle from degrees into radians, you just take that number and multiply it by pi over 180. That's it. That's the whole process.
Theory is one thing, but let's actually see this thing in action, right? Let's get our hands dirty and put the formula to the test, with a few examples, starting easy, and then cranking up the difficulty just a little bit. Okay, let's start with a total classic, an angle you see all the time in trigonometry, 45 degrees. How do we say that in the language of radians?
It's always the same two steps. It's that simple. First, we multiply. We take our 45 degrees and multiply by our magic fraction, pi over 180. Bam, we get 45 pi over 180. Second, and you can't forget this part, we simplify. You got to ask yourself, what's the biggest number that fits into both 45 and 180? Well, it's 45, so we reduce the fraction.
And just like that, there's our final answer. 45 degrees is exactly the same thing as pi over 4 radians. See? Not so bad, right?
All right, ready to level up? Let's try something a little bigger. What about an angle that goes past a straight line? Something like 225 degrees. Does our process still work?
You bet it does. The process does not change, not one bit. Step 1, multiply 225 by pi over 180. Step 2, simplify that fraction. Again, 45 is our best friend here. It's the biggest number that goes into both, and that leaves us with 5 pi over 4. It's the same exact method. And boom, there it is. 225 degrees is precisely 5 pi over 4 radians. The method just works. It doesn't care how big the angle is.
Okay, one last challenge. What happens if we throw a curveball? What about a negative angle? Let's try to convert negative 150 degrees. It might look scarier, but I promise you already know exactly what to do. And here's the beautiful part. You don't have to do anything different. That negative sign, it just kind of hangs out and comes along for the ride. We multiply negative 150 by pi over 180. Then we simplify. The biggest number that goes into both 150 and 180 is 30, and that reduces our fraction perfectly.
And there we go. Our final answer is negative 5 pi over 6 radians. So now we know for sure, positive, negative, big, small, this two-step process can handle absolutely anything you throw it at.
Okay, we've got the process down. Now let's talk about the traps. These are the common mistakes that'll cost you points on a test, and I want to make sure you can see them coming and avoid them. This is, without a doubt, the #1 mistake people make, using the wrong fraction. Think of it like using the wrong key for a lock. You have two to choose from, pi over 180 and 180 over pi. When you're going from degrees to radians, you need to introduce pi into your answer, so you want pi on top. People mix this up all the time. So how do you remember which one to use? I've got a great little saying for you. Just repeat this to yourself. Degrees to radians, pi goes up, degrees go away.
Pi goes up reminds you to put pi in the numerator. Degrees go away reminds you to put the 180 in the denominator so it can cancel out the degrees.
And the other big trap? Not simplifying your fraction. Look, getting an answer like 120 pi over 180 is, okay, you're on the right path, but you're not done. It's like baking a cake and not putting the frosting on. You have to finish the job and reduce that fraction all the way down. Not doing it will definitely cost you points.
So you might be thinking, okay, this is useful for my math test, but am I ever really going to use this? Oh, you have no idea. If you've ever played a video game, you've been using Radians the entire time, even if you didn't know it. Think about the biggest game engines out there, like Unity and Unreal. Under the hood, they're not thinking in degrees. All their internal math, the physics, the character movements, the animations, it's all done in radians. An artist might type rotate 90 degrees into the editor, but the engine immediately, silently, converts that into pi over 2. And if you're a coder, you have to do that conversion yourself. If you forget, your character won't turn 90 degrees. It'll barely move at all. So what you're really doing here isn't just learning some random formula for a test. You're learning the secret code behind digital physics. You're learning the hidden language of 3D graphics and animation. It's pretty cool when you stop and think about it.
So there you have it. You now have the complete toolkit to go from degrees to radians. You know why it's so important, and you know what common mistakes to watch out for. You've built a solid bridge from one system to the other. But that bridge goes two ways, doesn't it? What if you need to start with radians and get back to degrees? Well, that's a story for next time.